as I introduced them at the beginning, we have for this panel joining us Ani, who you've already heard talking. We also have Anoop, Jukka, and Toni. And just a reminder that you can drop the questions on the chat window, and we will make our best effort to make sure that they get answered during the panel. And also, if you want to be a bit more outgoing, if you're not that Finnish yourselves, then we will have an open question section in the end when you can interact maybe a bit with the panel speakers. So let's get this party started. First question is in plain English, if you can explain what is the Kubernetes architecture and the components and how do they work?
Yes, and I believe that question was set for me.
Yes.
All right. Yes. Okay. So I will try to talk at a very general level because I don't really know what's the background of the people here. There might be people who don't have a previous exposure to the architecture, and also digress a bit to different Kubernetes distributions, which might be interesting for more experienced people. So about Kubernetes architecture, there's many Kubernetes distributions, and they don't necessarily have completely the same architecture. So to be a CNF certified Kubernetes distribution, your Kubernetes API needs to pass a set of automated tests. So in a way, you can think of Kubernetes even as a set of as an API specification. So in theory, I think it would be possible for somebody to come up with a Kubernetes distribution that has a really weird blockchain-based architecture or something like that. But in practice, we don't really see it. I think most of the Kubernetes distributions go in very similar directions and have very similar architectures. If any of you have found out some really weird Kubernetes architectures, feel free to post it in the chat. All right, next slide, please. So at the 10,000 feet level, we can split the Kubernetes architecture into control plane and worker nodes. So control plane is the part that is responsible for running the Kubernetes itself and coordinating it. So this control plane itself is composed of various components like API server and a cluster data storage and so on. And worker nodes are the part of the cluster that actually runs the stuff you put into Kubernetes, your workloads. So it could be bare metal servers or virtual machines or your laptop or serverless Fargate virtual machines or whatever. It doesn't matter as long as it can run stuff. And each node also has various components that make it possible for this node to work as part of Kubernetes. Next. So here we have a diagram by Lucas. Thank you, Lucas, for giving this for me to use. And if you look at the center of this architecture, you can see there's the API server, and all the other components only talk to the server. So none of the components talk to each other directly. And if you look at the user also only communicates with the API server. Maybe they are using a command line tool like kubectl, or they are using some graphical user interface. It doesn't matter. In the practice, the user is only communicating with Kubernetes through API server. And that's why you don't really need to understand the architecture necessarily to use Kubernetes. You can just treat it as a black box that does what you want, and you will get along pretty well. To understand how Kubernetes does, can you go back?
Oh, sure, sorry.
Yeah. We can think of an example of a case of somebody using Kubernetes to, let's say, running 3 containers that run Nginx web server. The user sends the configuration, that specifies that you want to run 3 Nginx containers to API server, and controller manager that is looking at what is happening through the API server sees this. It takes this resource and it transforms it to a set of pods to run in Kubernetes. Pods are like the basic unit of workloads in Kubernetes. And these pods, along with the configuration that the user sent before to the API server is stored in this etcd, which is the default key value store for storing Kubernetes cluster state. And when these pods appear, the scheduler there on the right sees it, that sees through this API server, and it defines which pods should run in which nodes. And it again sends this information through API server. And then finally, these pods are scheduled to run in the nodes themselves. And the nodes again get the information through API server. This is like a very high level explanation of how Kubernetes does what it does. I hope it's helpful to somebody.
It's quite high level, yeah. Very, very big picture.
All right, next slide, please, Alex. So Anoop challenged me to explain also architecture of K3s and K0s, which was very nice. I wasn't very familiar with these projects, so I researched them a bit and look at their architecture just to find out how it's different from, let's say, vanilla Kubernetes, which I was explaining before. If you look at this K3s architecture, it's not very different. One difference is that their default data store, instead of etcd, it's SQLite. And there's a tunnel proxy for communicating between agent and the server, which is basically the same thing as the worker node and control plane we were talking about before. One interesting difference is that there is each of these only runs in a single process. So you see there's this dotted line that says process. And that means that in this K3s agent, all of these components like kubeproxy and kubelet and whatever, they are running in the same process. And this is a way that K3s saves memory. So the K3s is basically a small memory footprint simplified Kubernetes distribution originally created by Rancher. It's for running Kubernetes in Internet of Things and the cloud. And this is like the architectural method by which they make it possible to run it with a smaller memory footprint. Next, please. All right, K0s is another Kubernetes distribution. It is in a way similar to K3s, but where the goal of K3s is to be small and light for Internet of Things and the edge. What K0s is all about is about, let's say, in my perception, it's about ease of installation. So it's all packaged in one single binary. As you can see here on the right, where is the K0s.bin and all the various components that we were looking at before, and some that are different or named differently are contained in this single binary.
And Jukka, sorry to interrupt you, but one thing that Lucas just dropped in the chat, and I think it's worth mentioning, going back to the K3s, it's that now it's a CNCF project as well. So even though you mentioned it was originally developed by the Rancher Lab guys, it has matured enough to be promoted to the CNCF.
Yes, indeed. All right, you can go forward. And next one. Yeah, here is the control plane in K0s architecture. And here you can see it's like there's again this one single binary that you need to kick off a Kubernetes control plane in your server or virtual machine or whatever, with all of these different components running there. Can you go next one?
Sure.
And the same one with worker nodes. Again, you start a single binary which takes care of running all of the components that you need for a Kubernetes worker node. And this is the end of my answer, and I'm now eager to hear further comments from my fellow panel participants or from the audience.
Well, there's already one question. What is the K0s API, and does it have its own server, or how does it work?
I think it's just it's this. This is again from the perspective of someone who hasn't gone really in depth into this K0s, but it's I think it's just the same Kubernetes API, and maybe they have implemented some of the API functionality on their own. Maybe they haven't, but I would be surprised if it was different than the regular Kubernetes API, just packaged into the same binary for K0s.
Sorry, Anoop, have you been using this K0s since it was your challenge for Jukka?
No, I have never been using it.
All right. Yeah, I guess it's still a fairly new project. Like it's one of those ideas that sound very, very promising, but it's still like starting to get adopted. So it's very kind of a niche technology, you know, like there's not that much people who have been using it. And well, if there's no more questions for now, then we can move on to the second one, since we are also talking about Rancher. There's the second question. With all the pros that Rancher brings, why do you think it's still not as widespread as Kubernetes or as popularly adopted? And for that, I think, Toni, you're going to give us a short introduction to Rancher so that the people who are not familiar with it can get a clear picture.
Yeah, hi. So, it kind of makes, okay, you already went. So Rancher is Kubernetes management platform. So it's not a Kubernetes itself, but it has a, Rancher is also a company, Rancher is a product, and Rancher has Rancher Kubernetes engine. So a lot of things are called Rancher or has Rancher in the name. So maybe the question was a little bit coming from that not clear what Rancher really is. So I'm not going to give like a sales presentation of Rancher, but I just want to highlight how we at Monto use it and what we found to be working for us. There are a lot of features that we are not using and so on. But let's see how our organization is using it. Okay. Alex.
Do I go back?
Well, yeah.
I'm trying to read on the gestures, but if I skip it, then just let me
know. I do this next time when you.
All right.
Okay, so 100% open source, and Rancher Labs developed it originally, and Rancher Labs is now part of SUSE. And I think Rancher has at least one other project which is CNCF track on CNCF track. Okay.
Yes.
Next. So what we use it for, we use it to simplify our cluster management. This is a screenshot of production clusters that we monitor and take care of. And it includes AWS clusters, AWS Ecos clusters, Google clusters, RKA provisional clusters, so they are all of the clusters or most of the clusters that we take care of are consolidated in here, so we can have a simple way to look at them and have our like Monto Care personal on-call officer to go in and inspect problem if some cluster has a problem. Next one, please. So we build clusters differently. There are many ways. Terraform is a nice way to build them, and we have 2 ways of doing this. Or basically, there are many ways, but we use mainly that we use Terraform Rancher provider. So we call the Terraform against our Rancher, which creates the cluster. Second one we use is the RKA, which is kind of the engine of Rancher, the Rancher Kubernetes engine is called, and that is a command line tool that has also Terraform provider. So we just define the clusters and it sets up the cluster, and then we have to manually import it to our Rancher interface. And then there's a nice way of when you need to do something quickly, test or evaluate some product, we just click and create the cluster through the Rancher UI. And of course, there's the importing. Next one. Now you have to click once. So, so what it brings, because you saw that we have at least 3 or 4 different kind of clusters, we get unified meters to all of our clusters. So Google clusters, AWS clusters, Azure clusters, they all have the similar like dials or meters, click once, what we use to check the health of the cluster. And the other thing that we use is the Grafana, which comes quite nicely packaged in Rancher. So we have a customizable, ready packaged Prometheus Grafana instance. Click once more.
Yep.
So we have kind of the dials for all the clusters unified like this. Okay. So we use it to update our clusters. This is, of course, not all of them can be updated through the Rancher, but ones which have been provisioned with RKA or Rancher itself can be updated kind of like this. So it has 3 versions of Kubernetes usually available. And yeah, it makes life simple for people who might not be so much into Kubernetes. So this makes even the updating a little bit more easy and easy to approach than doing it the Kubernetes hard way, for example.
If it's not your priority to manage everything from the command line and you just want to run the cluster, then it makes it definitely easier to handle.
Yeah. And another feature we use is like this. We have 2 approaches. We can use this global Rancher global DNS feature, but it has a little bit limited set of providers. But we happen to use Cloudflare and Route 53, so we use this in combination with Cert Manager, which comes next, but to direct the workload, the traffic to our workload. External DNS has a little bit more providers that can be used, but I think they are based on the same principle that when you annotate something on your ingress, it will automatically create this DNS entry for you. And which is really nice when a developer can just make an ingress and doesn't have to think anything what happens after that. After a few minutes, he has a working DNS entry to his program he's developed. Next one. Certificate management is always, if you are not doing it daily, it's always like, usually the certificate has gone old and you have to fix it now, and you don't remember anything what happened 2 years ago when you last did it.
And the client is on fire.
Yeah, so this is one way of doing it. It is not actually a Rancher feature. It's just nice UI that works with Kubernetes certificates, but it makes life easier sometimes when you need it. Other thing we use is Cert Manager, which is CNCF project which issues the certificates automatically. And actually, what you're seeing now is how Rancher shows you the automatically provisioned certificates.
And I think you just said something which is quite like one of the main values for Rancher as a tool, which is that even if it comes with very nice things, the let's say like the nicest thing is that it gives a very friendly and a very simple interface in which you can see all these things that you can also access them through the to the command line, but it gives you this tool in which it's easier to have everything handy on the same place.
Yeah, it basically, let's face it, not everybody in organization is CKA certified, whatever I happen to be. But okay, you have different levels of understanding of Kubernetes, and Rancher is a nice way to give first read-only access, that this is our workload, this is our thing. If something goes, if some alert rises, you can go and look and try to see what is the problem. Of course, then when you are more seasoned Kubernetes user, you take kubectl and use it, or you can mix and match. Sometimes on a train, you might not have access to your kubectl. You can just look what is happening through the phone, and that's nice backup. So what we use Rancher frequently is, well, user and group management to give access and manage the access of people who need to access the clusters. For developing and debugging, I quite often evaluate some project with completely fresh cluster, just there's nothing running on the cluster, and I just know that, okay, now if it works, it's the thing I'm evaluating is set up correctly, and then I can go some other cluster and try how it works there. And rapid prototyping, just clicking through UI and having a pod running, and when you are satisfied with the result, I sometimes take the YAML as a basis of the actual YAML that is going to be in GitOps, for example.
Yeah, and I think also one comment that Lucas just brought up, we were talking about this during the previous session that we had planning this meetup, is that as we were talking, like Rancher, it's like a specialized tool. Like it's not like Kubernetes is the core. It's like the foundation for everything. And then on top of that, you can have different platforms or different tools. And then Rancher, it's just one of those tools. So it's even though it might have all these nice things, it's not still like it's just like a user interface, to call it somehow.
Yeah, exactly that. If you have Rancher installed, you cannot run any workloads. You need the Kubernetes cluster that the Rancher manages. And quite honestly, if you have only one cluster, Rancher might not be for you, because then you have the overhead of running the Rancher and then one cluster. But as in the first few slides, we have many Kubernetes clusters that are running, and we monitor them. So it's really makes sense for us to use it. Here's just features that I have not been able to really dig into yet, but there's interesting things like Longhorn, which is a distributed disk made by Rancher company. The new Rancher UI, which makes the digging into your workloads even more intuitive. Okay, and all of this, you can see that I have not even looked at yet, but they are readily available in Rancher if needed.
And there's a question for Toni from a different Toni. He's asking if it's possible to manage the Rancher 2.5 add-ons from the command line, since all the docs point to this new Explorer UI, or like how do you manage all these add-ons, like Prometheus, for example?
Yeah, it's like the configuration of Prometheus and Grafana was new in, like that it can be customized, is new in 2.5, and I just started to dig into it. So it is done with config maps and like with YAML, so kind of with command line, yes, but I'm not very confident to answer that because I just started to look into it like last week, or when did we update our Rancher to 2.5?
Right, but it seems like they use the same underlying Kubernetes object, so it should be possible to do it somehow.
Yeah, if I remember now correctly, it was config maps or that define what kind of, or was it a custom resource definition for alerts? When you define like Grafana alert manager alerts, it might be custom resource definition, and some of configurations were config maps, like so with YAML anyway.
Okay, so it is possible. Thank you. Hope, Toni, that it helped clear out your question.
Also, Olli has commented that the Longhorn that Toni mentioned is another CNCF project from Rancher.
Yeah. So K3S and Longhorn are the two CNCF projects.
Yeah, that so far they have graduated. And well, now to make use of the experts that we have around, we have a question that's a bit more generic that we could discuss about, which is, what are your preferred or your favorite ways in which you can provide access to external apps to your Kubernetes cluster? So I think for that we can hear from each of you what's your sauce.
Should I go first?
Sure.
The first alphabetical order. Well, I don't know. I just presented about Linkerd, so I would go for Service Mesh or Linkerd, or those kind of things.
All right. What about you guys?
One approach I would take for on-premise cluster is there is something called as, because the challenge with on-prem cluster is the DNS. So usually when you define your Kubernetes service as a load balancer, or you were to define some kind of an ingress, this is not automatic. So in an on-premise cluster, you basically have your own DNS and so on and so forth. So one approach is that gets challenging to give an access to basically to ingress all the traffic from an outside world into the Kubernetes cluster. So one approach, what I found useful was Metal LB. You can take a look. It's an open source project from Google. So that was my approach when I did try to do ingress traffic into an on-prem cluster. So this has nothing to do with the cloud. Thanks.
Yeah, thank you. And Jukka, what about you?
Yes. Well, the thing is, like, I don't think I have a standard one true way of doing this. Like Toni was earlier explaining about the way we do it at Montel via Rancher. And if I was working in Montel cluster that is suitable for this, I would use the same method. That would be like my first thing that comes to mind. I would just like to add something like, because of course the main thing we are talking about is how to get an endpoint in the web that is accessible and that you can, for example, serve your application or API from. But often we get situations where we just want the access to ourselves, or let's say a team member, or for whatever reason we don't need to do the full shebang of having a nice domain name with an URL, and we don't need to have a TLS certificate. In that case, we can just use the simple kube control port forward for our own debugging, or we can use cluster IP type of service. No, sorry, not cluster IP, like external IP or whatever it's called, in which case you just expose an endpoint at the IP address of a node, which is usually far faster to do if your purpose is just simple debugging or providing something for your teammate to look at.
Yeah, it sounds like it's a bit more compromising in a way, like you're exposing not only the workload or not only the corresponding endpoint, where you're exposing like the actual whole node. So yes, as you said, just for the debugging purposes, it works fine.
No, I mean, usually the node itself is generally exposed. It has its own external IP. It just doesn't have like publicly accessible ports necessarily. This just means that you open one port to one workload.
Oh yeah, well, you make it accessible, yeah.
Well, I could comment like, of course, it depends really where you run your cluster. So if you are on big cloud provider, there might be kind of standard ways of doing it. But as we have been running clusters, for example, smaller cloud providers, and there's not so much infra around you that you can use. So I have come up with these 3 projects that will work anywhere, but maybe not make most sense when you are using, for example, in Google cluster. But okay, so first thing is the DNS. As I mentioned already, the external DNS is there to expose your node IPs to a given name. That is the first part that get the traffic in. Then there is a really nice project which is Nginx Ingress, which just is driving Nginx in one container and just converting your ingress definitions into Nginx configuration. That is the second part. And the third part is the certificate manager. So you get everything to HTTPS. So combining these 3, and if they are correctly installed in your cluster, the developer can just make ingress and have 2 annotations. One is for DNS name and one is for that I want certificate for this. And after a few minutes, you have an endpoint exposed to the world with certificate already done.
Yeah, and that one brings a bit more, how to say, more like power, or like more, it makes the developer more productive. So then you don't rely on having an ops person giving you an ingress every time you need it, but it's so easy to configure that any developer can just, of course, carefully create their own ingresses and just manage it themselves.
Of course, if you type the domain something really weird, of course, the configuration is there that you can only provision names from Montel domain or Montel.care domain in our case. But anyway, it's really nice, at least for development and these kind of operations. Really nice setup with these three projects. I think they are all CNCF projects, by the way.
Probably, Anni, you can confirm. But we have another comment from Arslan. He's one of our Monteliers, and he's suggesting that for quick debugging, the port forwarding it's a good option, or directly updating the host files with the public IP and the domain if the external DNS is quite slow. So where there's a will, there's a way. So everyone has their own tiny tricks, and well, those are our experts' recommendations. So now we can move on to the next question, which is for Anoop. And it is, what do you think about the new Google Autopilot?
Yeah. So Google Autopilot, so I presume the question was more like, what are your thoughts about the new GK Autopilot? I would say, so GK Autopilot is a new mode of operation with Google Kubernetes Engine. So Google Kubernetes Engine is a managed Kubernetes provided by Google, and they have now taken a one step forward, actually easing out users by introducing GK Autopilot. So for that, to make a comparison, I'm probably going to compare a little bit of like apples and oranges. So it's not really good to compare a hosted Kubernetes engine versus GK Autopilot, but I would still continue to do so because I see that a lot of adoption for the hosted Kubernetes engines in the customers and all around the world. So so I would actually take this question like, what if can I go to GK Autopilot, or what does it mean to go to GK Autopilot? So in a high level, as I mentioned, GK Autopilot would abstract the control plane and also the slave node. So the idea is that, okay, let's get back to the hosted Kubernetes engine first of all. So in a what is a hosted Kubernetes or a managed Kubernetes engine? It was like when so the control plane is actually provided by the vendor. So you don't actually have to worry about the control plane. So you don't have to take care of your API server and kubelet and so on and so forth. So it's just provided by the vendor. And then there are nodes which are actually the ones which actually cause the billing, and that's where you run your workloads. So in managed Kubernetes cluster, you could actually get a full control over your access, security, logging, monitoring, scaling, etc. And this comes out of box. There is for Azure Kubernetes cluster, Google's and the Amazon's, they all come out of box. So this is not going to change in GK Autopilot. So GK Autopilot is actually going to retain all these things. So it's not going to change there. However, the biggest change comes in the billing. So the idea is that until this point, when you run managed Kubernetes cluster in one of your cloud vendors, you would be basically billed per node. So if you start a Kubernetes cluster, then your billing basically starts, irrespective of the fact that you run workloads on it or you don't. For the GK Autopilot, they went one step forward, starting to claiming that, okay, the billing or the SLA is basically per pod. So basically per your workload. So how does, and the pod is actually requesting for a resource, right? Like, so it needs a certain amount of vCPU, it needs a certain amount of memory, and that's what is actually going to the billing. So the idea is this, that Google thinks that it would actually saves a tremendous amounts of cost for the customers. So there was also a claim that some big customers would actually even get 50% benefit if they are moving to GK Autopilot. However, so there is like, the with control comes lots of responsibility. So in the sense, when you have less control in GK Autopilot, you have less responsibility, you have less control. So in the sense, one of the feature a lot of people would actually love to use is the node affinity, which would not work in GK Autopilot. There is definitely pod and anti-affinity, pod affinity and anti-affinity, but in GK Autopilot, you don't have the node affinity because you don't basically control the node. Basically, you don't control how the nodes are upgraded and so on and so forth. So all the security patches and everything is comes from the vendor itself. So that's one of the drawbacks with that. And also at the time of release, which was just released last month, they mentioned that there is only support for container optimized operating system. So which is a kind of a Google's own COS operating system for containers. And that's the only operating system supporter. So if your workload is actually running on Ubuntu or Windows, GK Autopilot is not for you. This also means that you cannot run privileged containers. So in general, which is very much specific to your operating system and so on and so forth. So was it like 2 weeks ago when GK Autopilot was released, I did a spin, right? Try to run one of our test workload, it worked. And then when I tried to partially deploy a production workload, it kind of failed. Then I saw that inside our production workload, we have mentioned node affinity, and that doesn't work. So from the from the Google's point of view, GK Autopilot is something they've just launched. They would actually recommend people to start using in their dev environments. However, over time, if things work out really well, and they would recommend to move from dev to the prod. So they don't even recommend right away, though it's in a GA state, general availability, but still Google doesn't recommend. But I wanted to actually highlight something here. So in 2015, when GKE was introduced, 2014, when Kubernetes was actually open source, and 2015, when GKE was introduced, people were actually kind of worried and wondering, like, okay, the control plane is going to go into the vendor. So you don't actually have control with your API server's process or if you want to pass an extra parameter and so on and so forth. It's not possible. So people were actually a little bit worried. And then Google made this kind of a drastic step. And then, however, I think that at least they managed to get most of the customers to adopt into this kind of approach. And hence, Amazon and Azure, they all followed this approach because it was really easy to use. You just go and click cluster, it's ready. You can actually start spinning your workloads and so on and so forth. So GK Autopilot, I think it is definitely a step in the right direction for Google. There could be drawbacks with this. However, Google claims that GKE, the standard mode, is going to stay, and Autopilot is also going to stay. So it's not that they are phasing out. So in a sense, GK Autopilot is definitely worth a try, I would say. If you do things with the limitations, if you know the limitations and if you do it kind of in a Google's way, like in a correct way.
So this Autopilot is, well, for people who don't know about it, including me, if I understand correctly, it's kind of like a simplified version of GKE, in which you can get some savings depending on which configuration you use, but at the same time you compromise some of the customization that you could have if you were running your own cluster. Yeah,
exactly. So you don't have to start paying for your nodes. You might actually run a bigger nodes, and then you could actually define scale sets on the nodes. Usually their claim is that the workload is not utilizing the full resources. Because when the server is like fully utilized, your performance is going to go down. So in the sense, you might actually have failure requests and so on and so forth. So that percentage of buffer is actually something which we are paying, and Google says that would actually be saved if you go to GK Autopilot.
So it feels kind of like a trend towards this the same approach that Amazon, for example, introduced with the Lambdas, in which you were not paying for the whole server, but you were just paying for what you were using. So you just like spawn the function that you're using, and then that's it. You just pay. And it sounds like it's kind of going towards the same trend.
Yeah, exactly. So I kind of listened to one of the podcasts, and then there was a question like, hey, now that you're making a step towards savings, why don't you go to basically like serverless, so basically like nodeless? Why don't you go to nodeless Kubernetes? So in the sense, only for the not even for the workload, but only for the request and so on and so forth. So kind of the reply was like, it breaks the stateful sets and so on and so forth, which is one of the requirements of, as mentioned, that it's a requirement of API requirement. But still, I think there would be time when we are going in that direction too. That now, as of today, if you even in GK Autopilot, if you run a pod and no requests are not served from the pod, then you're still going to pay. But anyway, that's probably definitely in their list. So that was a very nice question. So there is also people asking about why should you, instead of taking this intermediate step, why don't you just go to the nodeless approach?
Yeah, exactly. Why not just quit cold turkey? And there's a comment from Lauri Suomalainen on the chat about the GKE infrastructure management, that you still have to know how to operate the Kubernetes workloads.
I think this,
you're using this autopilot, it kind of removes some of that complexity.
Yeah, I think, yes, you still have definitely control on your manifests and so on and so forth. So
yeah. There are some differences, but it sounds like in many ways similar to Amazon's EKS by Fargate, or so-called serverless Kubernetes.
Yeah, definitely. So this is why I said that actually the comparison should have been like GK Autopilot versus Fargate and things like this, instead of talking from the hosted or managed Kubernetes cluster to GK Autopilot. But I think it kind of gives you a better picture, like, can I go to GKE or these kind of Autopilot-like projects from my existing clusters? Yeah.
In the end, it depends on what requirements do you have and how much are you willing to invest into it.
Yes.
Well, thanks, Anoop. I think it was a very good explanation, even for people who had no idea about what autopilot is, like me.
Yeah.
So,
me included. This was so new that I heard it last week.
Yeah, I think most of us just heard about it during our preparation session. So yeah, it's nice to hear.
Yes, yeah, just for you to know, this was just released 3 weeks before, so this is new.
So it might change at some point in the future. And now we have a question which I think it's quite, now that we have so many certified experts here, but I would like Anni to take the lead on this, since she's preparing for it. Should I or should I not get the CKA, the Certified Kubernetes Administrator certificate?
Yeah, it's a really good question. And how I kind of approach this now, that I will kind of give an overview on what it is, if someone doesn't know too much about the topic. And then I think in the end, I'll throw the figurative ball to the other experts to see their opinions and their experiences with this. But yeah, just to kick off, so what is actually CKA? So it's a program that was created by CNCF to really help develop the Kubernetes ecosystem. And it's essentially a way for users to demonstrate their competence in a hands-on command line environment. So very close to other certifications around as well. So in the next slide, we can see more closer, what does it actually comprise of? What does it include? So there's cluster architecture, there's workloads, there's services, there's storage, there's troubleshooting. So obviously the question itself depends on what do you, the asker, whoever they are, wants to learn, what they want to focus on, what they want their skills to be, how do they want to communicate to the outside world, what their skills are. So if the answer to those questions are close to the areas here, then very likely the answer would be yes. If not, then very likely no. But in the grander scheme of things, it depends a lot. And in the next slide, we can see a bit about how does the exam actually look like. So they are delivered online. They are consist of performance-based tasks, and it's like a real-world environment type of command line situation. They have 2 hours to do the exam. They are proctored remotely, and really quick results. In 36 hours, you should be at least getting your results there. And then we can go to the next slide. And I was trying to really hard before this find some kind of definite statement from somewhere that so many jobs are found by certified people or so many high impact of this. I couldn't really find anything definite per se, but I think one of the numbers from the recent CNCF survey really kind of highlights on how hot topic this is. So there you're talking about 121% increase year to year in the enrollments, which really means that it's really attracting a lot of interest, which then usually means that it is something that's worth spending your time on. And in the next slide, I've kind of, in my opinion, summarized the issue. I think certifications in general make a lot of sense. It makes sense to get them. They are a really great way to demonstrate your knowledge, really great way to learn skills. But it completely depends on what do you want to do? What are your interests? Do you want to find a job in the area, and is the field that you're looking into the kind of that really values certifications or not? So it is kind of or not decide you must. But yeah, I would be super happy to welcome the certified people in the expert group to talk about their experiences and has it increased their life satisfaction or has it not?
Has it made you happier?
Yeah.
So a couple of comments. I would say that the good thing with them is that you get to know other parts of or other functions of Kubernetes, which you probably would not be using in your day-to-day life. So that's one good thing that you're kind of forced to get to learn. The other thing is that one of the drawback I see with this certification is that it's just valid only for 2 years. So the people who got certified at the very early time when CKA was launched and would have already got their certificate expired, like me. So so that's one drawback with this, at least.
But at the same time, it makes you keep updated because Kubernetes is changing all the time. All the APIs and everything is changing, so it forces you that you always have to be up to date with what's up.
Yeah, that's true. So things have changed also in 2 years. Yes.
What about the other guys?
Yeah, there's some questions in the chat about CKA and CKAD, which are Certified Kubernetes Administrator and Certified Kubernetes Application Developer, how much they overlap, and is it true that CKAD builds upon CKA? I have actually only done CKA, and I haven't paid so much attention towards CKAD because I kind of wanted to do the more difficult and the more broad one. And that is my impression that CKAD is more for using Kubernetes, and CKA is more for using and administering Kubernetes. But I haven't really done CKAD, so I can't say this with any authority. If anybody has studied CKAD more, I would like to hear from them.
Yeah, it would be interesting to hear what's the overlap or what's the things that they have in difference.
Yes, and my own perspective on the CKA, that it's or certificates in general. There's two things that you get out of them. One is learning, and the second one is having the actual certificate, some let's say, a proof of your competence. And I found CKA quite useful for both of these, because if I was studying Kubernetes on my own, I would probably just, like Anoop said, I would probably just go for a narrow view of things. Like this, taking a certificate kind of forces you to like study it thoroughly, or at least as thoroughly as the certificate requires. And the second effect is that when the, let's say Montel is proposing to use me in a project with new client, it might be it has some effect on their view on my abilities if they see there's like 3 letters next to my name. Maybe not. Maybe they do.
It can be more expensive.
Yeah. Yes.
And I think,
and the same thing if you are going for a new job or you are a freelancer with clients of your own. Like there's this so-called sheepskin effect.
yeah, and building up on this that you're saying, I think it's from the business point of view, it's valuable even for the companies that if you have several people who are certified Kubernetes admins, then you can get these Kubernetes certified service provider, which again, it doesn't only bring value for you as developer, as admin or DevOps or whatever, but it also makes the company look better. So if you're like the boss and you're considering whether your employee should take it or not, then it's definitely a plus for the business as well.
People in the chat are commenting that Leticia is saying that clients ask for it, and Lauri is saying it does have an effect. Jukka, smile emoticon.
So yeah, it makes you look like you're even more professional, like you know even better what you're talking about.
Yeah, maybe I quite much agree with previous talkers, but one like critique maybe for the CKA is that people use command line we have very different setups for our command line and what tools we use and how we use, and then you go to the certification and hey, you can only use Tmux and you can only use this and this, and copy paste doesn't work, by the way. That was the early CKA exam, that copy paste was limited or not working. So that was the not so funny part of CKA, but otherwise it's like I said, good to have certifications.
Yeah, I guess it can.
What it means is that you need to be able to use Vim and Tmux and move from your lesser code editors to the one true way.
Yes.
Yeah, it kind of forces you to go back to basics. Well, thanks everyone for participating on this one. I think it's definitely a hot topic, and most of you would be interested in it. Now I will cool it down a little bit with a slightly different question, which was focused for Jukka, actually for you. Since we're talking about Rancher and this whole Kubernetes ecosystem, if you don't want to go with Rancher, what other options do you have?
Yes, and this is an interesting question for me, because I wasn't really aware of the alternatives until like a few months ago, when a client project kind of forced me or encouraged me to look into these things. So when we look at alternatives, we should first think about what Rancher is. Toni already gave like a nice introduction to it, what Rancher does. For people, it's a Kubernetes management platform. So with Rancher, you can install Kubernetes to multiple different environments. Maybe it's a cloud provider made from one of the big 3, Amazon, Google, Microsoft, or maybe it's something like Hetzner, or maybe it's your bare metal cluster. You can install cluster there using Rancher. But you can also manage all your clusters in one place, whether they were created with Rancher or not. So even if you have a, let's say, Google Kubernetes engine running Kubernetes Google Cloud, you can view and manage it from Rancher almost the same way as if you had a Rancher created cluster. So that's the perspective I took when answering these questions. Of course, for installing Kubernetes, there's like tons of different tools. So I took like a bit like a more narrow perspective. So if you look at the vendor alternatives, there's OpenShift from Red Hat and Cisco IntroSite and VMware Tanzu. I don't really operate in this space, so I don't know that much about them. But for example, OpenShift is the kind of like something that really expands on Kubernetes. They come with their own inbuilt container registry and specialized tooling and things like this. And yeah, these are like, let's say, paid vendor alternatives that do many of the similar things as Rancher does, managing Kubernetes. Right, next one. And then we have cloud provider alternatives. From AWS, we have or will have during this year with EKS Anywhere. So it's basically a way to install Elastic Kubernetes services on-prem on your own server farm or whatever. And you can also view all your clusters in one place, whether they are EKS clusters or not. From Azure, we have Azure Arc, where you can manage your clusters from one place. And you can also actually manage other things like your on-prem servers or virtual machines that run elsewhere. Azure Arc seems to be like the very like broadly featured. It doesn't seem to have features to install Azure Kubernetes service clusters on-prem. It's more like if you have clusters running anywhere else, you can bring them all under your single pane of glass management view and manage them from there. And you can also run Azure Arc enabled databases on any Kubernetes distribution running anywhere. And basically Azure will take care of stuff like backups and things like that. So it's like kind of like one place to rule them all, where you can bring everything to warm your cozy Azure home. And for Google Cloud Platform, there's Anthos, which is a way to install and just Google Kubernetes Engine clusters on-prem or multi-cloud, which means that you can install your GKE engines in AWS as well. And there's one place to manage them. So all of these like cloud provider alternatives and vendor alternatives are not exactly one-to-one replacements to Rancher. Some of them do more stuff and some of them do less stuff, and they all do different stuff. And I would guess they also do their stuff with different levels of like usefulness. And I guess whether you want to go with Rancher or something else, it depends on your situation. I'm personally biased towards open source solutions such as Rancher, where I'm not locked into anything and I can just like run it anywhere I want, and there is no risk of not being able to migrate away. But if you are in a situation where you're already working with one of these vendors, or you are really all in on one of the clouds, then it might make sense for you to go with one of these if you like their features.
Yeah, I think that's the only points for Rancher, that since it's, as you said, it's open source and it uses, in the very, very background, it uses these Docker machine drivers. So even if you have a very, these very like obscure indie cloud providers, but you have a Docker machine driver for it, you can just use it with Rancher. So you're not locked in with any vendor, and it's open source, so you can just build on top of it to whichever solution you might need. Yes.
Do any of my fellow panelists have comments on this?
I think, Toni, since you're the Rancher leading expert, you might also have an outsider experience.
Well, actually, I was surprised of all of these. Haven't really researched further. Like I found my happy place to be with Rancher, so I haven't looked anything else. But interesting to see that other cloud providers have been also waking up to this, that maybe people need something more than vendor lock-in Kubernetes.
Interesting thing is that I haven't really seen like during my research, I did not find any open source alternatives to Rancher. Rancher seems like the the only player in this particular game that is open source.
Oh.
Or if any of the people in the chat have found any, please write it there.
But what is the status of OpenShift? Isn't that kind of?
Is OpenShift open source?
Yes,
Alternatives.
OpenShift is open source.
Okay.
Yeah, and well, it also has the backing up from Red Hat, and for the people who already knew about Rancher before, Toni already mentioned they were acquired by SUSE some months ago. So now, even though they're still open source, they also have the backing from an open source company. So it's not a private thing, but it's still now supported by this company. But yeah, now that we have been talking about Kubernetes and Rancher and all this cloud stuff for a while, I think that the true essential core question behind all this talk is, when should you actually use Kubernetes? Should you actually use it at all? And for this, I would like to hear everyone's thoughts on these, since probably everyone's quite biased, but still.
That's always a funny flame war topic on Hacker News or wherever it's raised. The thing here is that it, of course, like everything else, it depends on your situation. Because if you happen to know Kubernetes well and you have a handy cluster available, why not run your cat picture block in Kubernetes? Because it's actually quite easy and convenient way to do it. So, and what is my personal perspective on how to run stuff now these days is that I don't want to keep pets of any kind. We think we use this expression, cattle, not pets. So let's say we have three kinds of cows that we could have. We have the traditional pets. We have these servers that we manage by our own hand, and we SSH to the server and we change their state. And okay, if we are lucky, maybe we have some nice Ansible script that means that we can kind of do it in a consistent way, but we are still worried about them on individual level. This is where I don't like to be. I still am there because I have projects I'm maintaining that work like this, but I don't really like it. Then we have Kubernetes, where we kind of treat our servers like cattle. It's nice. I like it. It's good. On the other hand, if you don't know Kubernetes and you don't have and you have to set up your cluster yourself and learn Kubernetes first, maybe that's not for you. And there's the third alternative, which is like a platform as a service, let's say Heroku, or a new feature of Docker Compose, where you can run your Docker Compose setup as by Elastic Container Service in Amazon, or Dokku, which is kind of like your own personal Heroku clone, or even functions as a service. These are all like a third alternative, which is where you don't have cattle yourself. Even cattle yourself, you have somebody else taking care of cattle, and you kind of just go to them and buy the meat and milk from them. And I think these two are my selections. I don't want the pets. I want the cattle, or I want somebody else to take care of the cattle. The part where somebody else takes care of the cattle, the PaaS alternative is for simpler projects. I would probably even go for that first, if I don't happen to have a cluster handy for it already.
Yeah, definitely. No need to complicate beforehand.
That was very nice, Jukka. So I can kind of continue on that. So if you were to ask this question 5 years ago, then I would start to answer it in a different way. So as you all know, that Kubernetes is just not a single process by itself. There is a lot of servers involved. There is lots of processes involved, and so on and so forth. But the whole trend has changed in last 5-6 years. Lots and lots of open source and community, and as you see, Annie presented all the metrics and so on and so forth. As you look at the CNCF, the foundation projects and so on and so forth, it's like tremendous amount of growth. So definitely case by case. I mean, you don't want to run a very small thing, then you don't have to spin a Kubernetes cluster. But definitely if you were to choose something very similar to Kubernetes, I would definitely recommend Kubernetes here, because there is so much support on the internet. And as you see, like if there is an error or something, then you just go and paste it in the internet. There's lots of answers and support and so on and so forth. So over time, things have evolved. This has, and as you see, a shift from the hosted Kubernetes to the next level, where it's very, very easy. You don't have to care. It's just a black box. You write some YAML files and just push it, and then you get everything working. And I also see that there is also CI/CD has also improved a lot around Kubernetes. Backup solutions and lots of things have really come around and has grown this ecosystem so well. And I would say that, yeah, as you see, lots of production workloads, so I would trust this, the system itself. So definitely for very small things you shouldn't use, but on something similar, when you consider, I would recommend this due to the less effort and the community support and so on and so forth.
Yeah, probably the biggest selling point for Kubernetes is the community. Like there's a lot of, well, it's an open source project, so there's a lot of development and there's a lot of support. And like, as you were saying, I know anything that you might ask, someone has already asked, so you can just Stack Overflow it. And Annie, I would like to hear what are your thoughts about it?
Yeah, I don't have like too much to add in a way, since I really kind of, Jukka took the words right out of my mouth with the cattle and the pet reference, honestly. Like there's a time and place for everything. So not really too much to kind of say than to really say that I agree with my previous experts' opinions. And I will also post a really funny Twitter tweet that I saw the other day about running your personal blog on Kubernetes, if anyone wants to watch that short video. It was very funny. But yeah, that's from me.
Yeah, and then as Anoop was kind of building up, if you, as soon as your project starts scaling up, then if you have to choose which distribution to use or which container orchestrator to use, then Kubernetes has the backup of the CNCF. So it's not only the community, but then there's also some actual sponsoring behind it. So it's very well maintained. And Toni, you are our last expert missing to give an opinion.
Yeah, actually, there's not much to add on this. I'm just laughing to this tweet now. So everybody look at that.
Take a minute to go look at it, yes. Yeah, we're looking at it right now on this big screen here. And it looks, I mean, it gets the job done. It's definitely overkill, but you can always definitely go with Kubernetes.
Yeah, and well, I did exactly that when I was learning to use Kubernetes. Of course, you need to put your new tech skills into use, and I put a multi-node cluster running WordPress, and that was the only thing that was running there. But I got some good learnings out of it and how to run stateless and stateful workloads on it.
Yeah, exactly. If you're just going for learning purposes, then of course, why not? You're gonna learn how to use it, and then you're eventually gonna go for that CKA. So thanks to our experts for your very valuable and knowledgeable opinion. Now we have a few minutes left for open questions from the public. There was a comment before regarding these Rancher alternatives that OpenShift is open source, but in practice, the open source version is not 100% in par with the paid version. So there's some tooling issues with it. So you get almost the same, but you don't get exactly the same, which is then not the case with Rancher, in which it's open source from the core, so you get the same stuff whether you're using a certified provider or whether you're running it by yourself. So yeah, as I said, we have a few minutes left for questions, so bring it on. Don't be afraid. If you want to show your face, go for it. If you just want to drop it on the chat, you have 4 very smart experts here to answer for you. Okay, we have our first question. Alexander is asking about Helm. He says that he finds the template approach awkward and error prone, and if there's a way to heal that pain, and if there's any alternatives for Helm. So I think, Anni, this might be for you.
Yeah,
I hear the pain because I have done it. Please continue.
No, Toni, you take it. Yeah, you take it. It's okay.
I have one comment on this, however. I'm not going to suggest Helm alternatives, but I would recommend people to try Helm operator itself. Like, it's kind of an controller which is installed into your Kubernetes cluster, which would actually take care of running Helm. So if the pain is more like running it from command line, then push that also to the Kubernetes cluster.
Yeah, what my personal learnings was, I think, was it using Go as a template language, which was a little bit awkward in Helm, because I haven't used this. So the templating is nice if you know the templating language already. If you don't, then your kind of learning curve is kind of high. But I found that there is when you do your own personal thing and you have your own cluster, you put your product out and you're not even wanting to ship that to internet. You want to keep your own application in your repository. I wouldn't recommend using Helm. Then customize is better approach for that, because then it's just easier to template, easier to see what is happening. But when you start running your application like with different configurations, shipping it out to different outside to the world, then Helm, you just need to have the pain and write it. I found out that now when you start new Helm project, it gives you 90% of what you need for a typical application, or let's say 80% just comes out of the starter template for when you start Helm project now. But yeah, Helm and Kustomize, they are the tools that we use.
Yeah, Jukka he had just shared Kustomize few seconds before you dropped it, so it seems to be the common solution. Do you have any more questions coming up? Because otherwise, I had this one which came up. Well, Anoop was presenting the cloud Google Autopilot. Since there's now this trend where everything is serverless and everything is, the less management and the less that you have to do with it. General question for the panel: Do you see a future do you see the future as Kubernetes less? Like then, as Anoop was kind of mentioning, that you don't have to run the cluster yourself, but it's somehow run somewhere, and then you just push some configuration, then it's done. You don't have to worry about it. Do you see that as the bright future that we have ahead?
Silence.
This is not my opinion, because I don't think I have the 10-kilometer high perspective on Kubernetes or the ecosystem. I don't have that good big picture about it. But the way I've been listening to multiple podcasts on these topics, and many times, like the guests who are the experts who probably have this 10-kilometer broad picture of things, they have been saying that maybe in the future it will be like Kubernetes will hide itself. It will be the thing backing the platform, but the users will actually have a view of something simpler. So maybe this is will happen, but it hasn't happened yet.
Yeah, it's kind of a similar principle as with this serverless or this Lambda approach, in which it doesn't mean that there's not a computer running the code that you have, because, well, there has to be a computer to run it, but it's just that it takes away from you the requirement for managing the server and for setting everything up. It's just something it's given to you, and you just take some configuration, and then that's it.